starting with our first topic, that is number base. And by the end of this lesson, you should be first of all explain the concept of number base. Secondly, you should be able to convert from one base to base 10, a base to base 10. Let's say base 2, base 3, bases other than base 10. And also you should be able to convert from one base to another base other than base 10. That is, let's say from base 2 to base 3, from base 3 to base 5, and so on. You should be able to also use the calculator in changing from base 10 to base like base 2, that's the binary number system, to base 8, that's the octal system, and base 16, hexadecimal number system. And also lastly, you should be able to perform operations like addition, subtraction, and multiplication on number bases. And so we will start with the explanation of number base. When we talk about number base, what is number base? A number base is the combination of digits used in a system of counting. That is, let's say in base 2, you will be combining a certain number of digits, that's 0, 1, and those things. You should be able to know that. The most common system of numbers is the decimal number system. That is what we use in an everyday life. Base 10 can also be called the decimal number system, as I said, and it involves digits, all digits, that is from 0 to 9. We have digits 0, 1, 2, 3, up to 9. Those digits are used in base 10. When you talk about other bases, we have bases like base 2, which have a special name, that's the binary number system or binary numeral system. We have base 8, octal number system. We have base 6, that is hexadecimal number system. Base 16, hexadecimal number system. So if you hear a hexa and decimal, you get to see that it's base 16, hexadecimal number system. You should take note of all those things. In base 2, you should have only 2 digits being manipulated over there. That's 0 and 1. In base 8, you should have digits from 0 to 7. You shouldn't have a number equal or greater than its base in the digits. So that is what you should take note of. Base 6 is hexadecimal and base 16 is hexadecimal. Note, don't confuse yourself with base 6 and base 16, hexadecimal and hexadecimal number system. The hex on the Casio calculator or on any calculator I have ever used is base 16. Base 16, don't confuse it with the base 6, it is base 16. If you want to know that it's base 6, when you go there, you try to convert 6 using the hexadecimal. If it is in base 6, it would have changed, but since it's base 16, it wouldn't make any change. So number base is applied in computer technology. All computer language and programming is based on the 2-digit number system. 2-digit number system that is used in encoding and all those things. So that is what you should take note of. So we are going to start with solving of our questions, of which you will get a clear idea of what we really putting across. That is, we will start first of all to convert from one base to another base. So our first question will be converting from base 5 to base 10. And so let's start with it. So we will have a first question, that is express 2, 3, 4 base 5. With the 2, 3, 4 base 5, it will be written in this form. Looking at it, base 2, 3, 4 base 5 as a decimal numeral. So with the base 5, you write it as a subscript at the right side of the number combined digits. That is 2, 3, 4 base 5. A subscript at the down level, right down level of the numbers or the combined digits. And so with this, if you want to convert it to base 10, what you do is count the number of digits over here, starting from 0, 1, and 2. So 0, 1, and 2, with the numbers that are counted, you give it as a power, multiplying the digits that's combined. Let's say you are starting with it. You have 2 multiplied by the base 5 raised to the power, since this was 0, 1, and 2, raised to the power 2, right? Plus 3, that's the next digit, times 5 raised to the power 1, plus 4 times 5 raised to the power 0. And so with this, it's simply you just express it in the simplest form and then combine it, work out, and then you give your answer. That is 5 raised to the power 2 gives you 25. And so multiplied by 2 gives you what? 50. 50 plus 3 multiplied by 5 raised to the power 1 gives you 15. And then 4 multiplied by 5 raised to the power 0 gives you 4. You have to know that any number raised to the power 0 is 1, and 1 multiplied by 4 gives you 4. And so 50 plus 15 gives you 65, and plus 4 gives you 69. And so converting 2, 3, 4 base 5 gives you 69. And that is the answer for this question. Our second question says we should convert 1, 1, 0, 1, 0, 1 base 2. Base 2. As I told you, you write the base as a subscript. So base 2, 2, a base 10 numeral or the decimal number system. So with this, you also give them you count them. That is, this one begins to be 0, 1, 2, 3, 4, and 5. And so having it this way, you just have to start, take the first digit, multiply by the base to the power you gave it. So let's take it 1 times 2 raised to the power, the last digit was 5, plus the next digit, which is 1. 1 times 2 raised to the power 4, plus 0 times 2 raised to the power 3, plus 1 times 2 to the power 2, plus the next one, which is 0 times 2 to the power 1, plus 1 times 2 to the power 0. Having all these lined up, you just express it in the simplest form. That is, work out even with your calculator or raw works, and then you write down your answer. So looking at it, this will give you 2 raised to the power gives you 32 times 1 gives you the same thing, that is 32, plus 2 raised to the power 4 gives you 16. 16 times 1 gives you 16, plus 2 raised to the power 3 gives you 8. But then 0 over there makes it null, and so it will be 0. Plus 2 raised to the power 2 is 4. Multiplied by 1 gives you 4. Plus 0 multiplying this makes it null, and so it's 0. Plus 1 multiplied by 2 to the power 0. I told you 2 raised to, any number raised to the power 0 is 1. And so 1 multiplied by 2 raised to the power 0 is 1. And so if you have 32 plus 16, it will be 48. 48 plus 2 will give you 52. 52 plus 1 gives you the answer 53. 53. And so that is the answer for our second question. That is the answer for our second question. So we'll be starting with our third question. Now convert 225 base 10. So you have to write 225 base 10. 225 base 10 is also the same as 225 without any base, because written in this raw state is same as base 10. It's like writing 10 raised to the power 1 and 10 in this raw state, so they are all the same. So when you write a number without a base, we assume it to be in base 10. So that's what you should take note of. We are going to convert, it says convert 225 base 10 to base 8. And so if you are going to convert a number from base 10 to any base at all, that's base 8, you write 8 here, that is the base. And then you come and write the digits giving you 225, that's 225. This you can pronounce it in that way, that's 225. But mind you, in other bases like base 2, when you have something like 11011, you cannot say 11,011. No, it's never mentioned that. We have to mention the digits one after the other. That's 11011 base 2. So that is what you should take note of. So with this 225 base 10, we changing it to base 8. We have the base here, we have the number, that's 225, and our remainder on this side, and so we start with it. 8 goes into 225 how many times? It goes into 8, 28, and it gives us a remainder of 1. 28, and it gives us a remainder of 1. 8 goes into 28 how many times? 8 goes into 28 3 times. 8 times 3, it will give you 24. And so you have a remainder of 4. And so you check, can 8 go into 3? No. And so you have 0. Remainder 3. And so over here, when you get 0 in the middle, then you are done. You can't continue again. Work hard. And so over here, 225 base 10 is the same as you write the answer from the down part to up there. So let's say 341 base 8. So 341 base 8. 341 base 8. That is our answer. The question goes this way: express 25 base 10. That's 25 base 10 as a number in a binary numeral system. So having it this way, binary numeral system, we all know that it is what? Base 2. So you write the base, that is 2. You bring the number 25. The remainder here. That is the remainder. And so 2 goes into 25. How many times? Approximately how many times? It goes into 12, giving you a remainder of 1. A remainder of 1. Can 2 go into 12? Absolutely yes. And so 2 goes into 12 6 times, giving you a remainder of 0. Can 2 go into 6? Yes. 2 goes into 8 3 times and gives you a remainder of 0. 2 goes into 3, that's 1, and gives you a remainder of 1. Can 2 go into 1? No, it cannot go into, so it gives you 0 over your remainder 1. I told you when you get 0 in the middle part, that means work hard. You are done with the work. And so our answer will be 11001 base 2. Base 2. And so you write your answer this way: 25 base 10 is equal to 11001 base 2. So that is our answer for the 4th question. Starting with our 5th question. Our 5th question says convert 344 base 5 to base 7 numeral to base. So this is converting from one base to another base other than base 10. So 344 base 5 to a number in base 7 numeral. So what you have to do is, first of all, change this to base 10, and then you convert from base 10 to base 7. And so this is what you do. Converting to base 10, you give it numbers 0, 1, 2. And so saying this is 2, you multiply 3 by 5 to the number you give me, that's 2, plus 4 times 5 to the number you gave, that's 1, plus 4 times 5, that's to the power 0, right? 5 raised to the power 2 gives you 25. And so 25 times 3 gives you 75. 75 plus 4 times 5 raised to the power gives you 20. And so 20 plus 5 raised to the power 0 is 1. Multiplied by 4 gives you 4. And so looking at it, 75 plus 20 gives you 95. And 95 plus 4 gives you 99. And so now you have 99 in base 10. So you are now going to change it to base 7. And so you have 7 over here, 99 over here, and your remainder over here. That is what you do it. And so 7 goes into 99 how many times? 7 goes into it 14. 7, and then it gives you a remainder of 1. 14 multiplied by 7 gives you 98, and so 98 gives you a remainder of 1, right? 7 goes into 14 how many times? That is 2, remainder 0. 7 goes into 2 how many times? 0. 7 goes into 2 how many times? 0, remainder 2. And so you have 7 going into 99, 201. And so you have the answer to be this way: 344 base 5 is equal to 201 base 7. So this is your answer to question 6. That is express 441 base 6. Express 441 base 6 as as a number in base 3. As a number in base 3. So before we get this to base 3, we first of all have to convert it from base 6 to base 10 before we can convert it to base 3. And so we have converting it to base 10, we have to number the digits over here. So 0, 1, 2. Since this is 2, we have to multiply the number. That's 4 times the base 6 raised to the power 2, the number that was given to it, plus the second digit, that is 4 times 6 to a power, that is 1, the number that was given to it, plus 1 times 6 to the power 0. Having it this way, 6 squared will give you 36, and so 36 times 4 will give you 144. 144. 4 multiplied by 6 to the power 1 will give you 24, and 1 multiplied by 6 to the power 0 will give you 1. And so if you have 144 plus 24, it will give you 168. 168 plus 1 will give you 169. 169. So we have an answer in base 10. We now have to convert it to base 3. And so we have 3, 169, and our remainder. That is, we are going to convert it to base 3. We are going to convert it to base 3. And so 3 goes into 169. That is 56 times. 3 goes into it 56 times. And with the 56 multiplied by 3 gives you 168. 168. So you have a remainder of 1. You have a remainder of 1. 3 goes into 56 18 times. 3 goes into 56 18 times. And that 18 times 3 will give you 54. 54, giving you a remainder of 2. Again, 3 goes into 18 6 times. That is, 6 times 3 will give you 18. Remainder 0. Now we have 3 going into 6 2 times. Remainder 0 again. And then our last one, 3 goes into 2 0. Remainder 2. I told you when you have 0 in the middle part, then work is over. And so we now have our answer to be 4 4 1 base 6 to be equal to 2 0 0 2 1 base 3. And so you should go back and understand what I said, that with every number or combination of digits in a system, the numbers or the digits in there shouldn't be greater than the system. So you see, there is no digit over here that is equal to or greater than 3. Over here, there is no digit equal or greater than 6. So that tells you that what you said is what we are going according to. So with question number 7, it says evaluate 1 1 0 1 base 2 plus 1 0 1 base 2. And so it says we should evaluate. We have to bring it together and make it 1. And so over here we have to bring 1 1 0 1 base 2 plus 1 0 1 base 2. And so with this, if you are going to add, we do this way. 1 plus 1 gives us 2. 2, we look at it, how many times will 2, that's the base, go into 2? It goes into it 1, leaving you a remainder of 0. Over here we are well concerned with the remainder because the remainder is what we take as the answer. So it is going to be in base 2. And so you have 0 plus 0, giving you 0, plus this 1, of which the 2 go, that's divided this to give you that 1. So 0 plus 1 gives you 1. 2 goes into 0, that's 0. We still have the 1, and so the 1 is written. As I told you, our remainder is always our answer. And 1 plus 1 gives you 2. 2 goes into it, 1. 2 goes into the 2 we had, 1. And the remainder will be 0. We now have 1 over here, adding to, let's say 0 is over here, so it is 1. 1 plus this 1 gives us 2. So 2 goes into it, 1, and we have remainder of 0. With this one we still have, we bring it here, 2 goes into it, 0, remainder 1. And so our answer is 1 0 0 1 0 base 2. 1 0 0 1 0 base 2 is our answer. We go to our next question, that is question number 8. Question number 8. That is 4 1 4 base 5 minus 1 3 3 base 5. And so with this, you just go straight and then subtract. So you have 4 1 4 minus 1 3 3. This is in base 5 and this is also in base 5. You also will be giving an answer same in base 5. And so you can see 4 minus 3 gives us 1. And so we have 1 over here. All because the one that we had, 5 goes into it 0, giving you the remainder as 1, right? We also have 1 over here. Subtracting 3 from 1 is not accepted in this case. And so we go over here to borrow. As in the decimal numeral, when we borrow 1, because it is in base 10, when you borrow 1, it is 10. Over here, it is base 5. And so when you borrow 1, it is 5. And so you add it to this, of which it will make it 6. So over here is now 6. 6 minus 3 gives us 3. Of which 3, 5 goes into 3, 0. Remember the 3. Hope you get it. Over here we now have here to be 3. So 3 minus 1 gives us 2. 5 goes into 2, 0. Remember the 2. If you have here to be 0, you are done with the way. And so you have 2 3 1 base 5 as your answer. You have 2 3 1 base 1 as your answer. Question number 9. It says find the sum of 3 2 2 base 6 1 4 4 base 6 and 3 2 4 base 6 3 2 4 base 6. So over here you have 2 plus 4 giving you 6 and 6 plus 4 giving you 10. 6 plus 4 giving you 10. With the 10 we have over here, 6 goes into 10. 1, that is remainder 4. Remainder 4. And we have 2 plus 4 giving you 6. 6 plus 2 is 8. 6 plus 2 is 8. Plus this one, which will make it 9. 6 goes into 9. 1. Giving you a remainder of 3. A remainder of 3. Over here, 3 plus 1 gives you 4. 4 plus 3 gives you 7. 7 plus 1 gives you 8. So 8, 6 goes into 8. 1. Remainder 2. Remainder 2. Over here, this 1 will come over here. 6 goes into 1. 0. Remainder what? Remainder 1. And so we have our answer to be 1 2 3 4 base 6. Starting with the last question for the day, that's question number 10. And in our next lesson, we will have to go through a different set of questions that embroaden your understanding in the number base. And so with our last question, we have it this way. Simplify 3 2 1 base 4 multiplied by 1 2 base 4. 1 2 base 4. So we have 3 2 1 base 4 being multiplied by 1 2 base 4. And looking at it, 2 multiplied by 1 gives you 2. And with that 2, 4 goes into 0, giving you a remainder of 2. 2 multiplied by 2 gives you 4. 4 goes into it, 1, giving you a remainder of 0. 2 multiplied by 3 gives you 6. Plus 1 gives you 7. And so with that 7, 4 goes into it, 1, giving you a remainder of 3. Now we have 1. 1 over here, 4 goes into it, 0, giving you that 1 over here as the remainder. And so you go into 1. With 1, looking at it, when you multiply it by any number, it can give you a number 4 or greater than. So we just go straight to it. So we have 1 multiplied by 1 giving you 1, 1 multiplied by 2 giving you 2, 1 multiplied by 3 giving you 3. So that way it goes straight forward. So you have the base 4, and then you add the numbers. And adding the numbers, 2 over here, let's take it, the indents are 0. And so you get 2 over here. 4 goes into 0. 4 cannot really divide or go into it in such a way that we are looking for. And so we have a remainder of 2. We have it in base 4. 0 plus 1 gives you 1. 4 goes into 0, remainder 1. 3 plus 2 gives you 5. 4 goes into it 1, remainder 1. 1 plus 3 gives you 4, plus this one gives you 5. 4 goes into it 1, remainder 1. So we have this one, 1 over here. 4 goes into it 0, remainder 1. So we have our answer to be 1, 1, 1, 1, 2, base 4 as our answer. Thank you and goodbye for the day. Okay.